Okay, so we said that if we're looking out from the horizontal and we look down, that's what?
Depression.
It's the angle of depression. Now down here, these people are looking up at the top of the Eiffel Tower there. They're looking up, so that's the angle of elevation. Now, if my plane had moved, if my plane was over here, oops, that's not a good direction for a plane. Okay, y'all know I'm artistic, y'all love it. All right, so here's my plane. If those people were looking down, that would be this angle, right? The angle of depression, the little one I drew in pink there. But do you remember from geometry that if you have two parallel lines cut by a transversal, their angles, alternate interior angles, are equal? So in this case, where my plane is in pink, and my angle of depression there and that angle of elevation are going to be equal. All right.
Yes. That's correct.
So, what is the angle through which the eye moves up from the horizontal to look at something above?
Elevation.
That's your angle of elevation. And then what is the angle through which the eye moves down from the horizontal to look at something?
Depression.
The angle of depression. The key is, guys, it's got to be from the horizontal, okay? So many people try, if they have a triangle here, they try to make that angle of depression, that top one right there. It's not, okay? The angle of depression is not that top angle. It's the angle from the horizontal, so it's actually outside of the little triangle I had drawn. So just be careful on that one. All right, let's look at example 1. Says the angle of elevation from the buoy to the top of the, I don't know how to say that, so Ponce Inlet Lighthouse, 130 feet above the surface of the water is 5 degrees. Find the distance x from the base of the lighthouse to the buoy. All right, so it tells us the angle of elevation from the buoy to the top of the lighthouse is lighthouse 130 feet above the surface. So I know that my lighthouse is over here, isn't it? Because it already labeled it for me that it's 130 feet. The angle of elevation looking at that is going to be this angle right here, because if it's that buoy or whatever's over there, and it's going to be looking up. So it's the angle that's going up. And it wants to find x, the distance from the base to the lighthouse. The base of the lighthouse to the buoy. So from the base of the lighthouse to that buoy. So what do we know with that angle? We know that angle. What else do we know? The 130 is opposite. And x is adjacent. Which trig function can we use? All right, so we know that tangent of our angle is equal to opposite over adjacent. So let's fill in what we know. We know tangent, our angle is 5 degrees, equals what's opposite?
130.
Over what's adjacent. How are we going to solve for x?
Take inverse tangent.
Now let's get x off the bottom. You don't take the inverse tangent, guys, unless you're looking for an angle. We know our angle is 5 degrees. We're looking for a side, don't we? So no inverse here. All right, so when I multiply both sides by x, I've got x times tangent of 5 degrees on the left equals, the x is canceled on the right, so you just have 130.
130 divided by 10.
And then divide both sides by a tangent of 5 degrees. And so we get that x is equal to 130 divided by tangent of 5 degrees. And so what is that approximately? How are you going to find that? Put in our calculator. Do we want to be in degree or radian mode? Degree mode, how do you know?
So we're trying to find that we have an angle. We have a degree sign.
Because our angle's in degrees, it's 5 degrees, right? So make sure in degree mode, type that in, and what do we get approximately?
1485 or 86.
Yeah, so 1,486 feet. And that's what we were after, isn't it?